Hello, let's continue our Sudoku adventure with Going Steady by Calvinball. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6, exactly once each. We also have V's in the grid. V is Roman numeral for 5. What this means is the two digits that it touches add to 5. So we could put, say, 3 and 2 here. That adds to 5. That would be fine. Or 1 and 4. All right, we also have white dots in the grid. White dots separate consecutive digits. So if this was 2, this could be a 1 because 2 and 1 are consecutive. Or it could be a 3 because 2 and 3 are consecutive. Black dots separate digits with a 1 to 2 ratio. So if this was a 2, this could be a 1 because 2 is double 1. Or this could be a 4 because 4 is double 2. Basically, one of them is exactly double the other one. Bigger one's double the smaller one. Doesn't matter the order. Now, in addition to all that, the same clue, whatever cells those clues touch, you cannot repeat any digits. That's a special constraint on this puzzle. So if we make this one 2, 3, we can't repeat a 2 or a 3 elsewhere on V's. We could put a 2 or a 3 on a white dot or a black dot, but we cannot put them on another V. Now, if there's a 2 on a white dot, we can't repeat it on any white dot cells. If there's a 2 on a black dot, we can't repeat it on any black dot cells. And finally, none of the V's or black dots or white dots are necessarily all given. Just some of them are given. And so if we have, say, 2, 3 here, that would sum to 5. That would be perfectly fine. We weren't given a V, but it's still okay for them to sum to 5. Similarly, like a 2, 4, there's no black dot. 2, 1, there's no white dot. All of that's perfectly fine. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so I'm going to start by penciling these V's, 1, 2, 3, 4. And I immediately notice that because we can't repeat digits on the V's, and because only 1, 2, 3, 4 is possible on a V, because 5 or 6 can't add to 5 with another digit, because there's only 4 digits and we can't repeat any of them, these are going to use up all of 1, 2, 3, 4. Another way to put it is one of these will be 1, 4 and the other will be 2, 3. I don't know which is which. But what I do know is that these two cells here see the entirety of the V's, right? They see this pair and they see this pair. So they can't be 1, 2, 3, 4, forcing this to be a 5, 6 pair, making this a 1, 2, 3, 4 and this a 1, 2, 3, 4. Okay. And I can actually color the 1, 2, 3, 4s, which may or may not be useful, but I like coloring. So we'll call this the green pair. I don't know if it's 1, 4 or 2, 3, but these are the two digits that go on this V, and we're going to call them green. Now, because these share a box, these are then the purple ones, because they can't be the green ones. So these are the green 1, 2, 3, 4s. These are purple ones. Remember, these two can't be the same as these two, so these have to also be the purple ones, which for this column then makes these the green ones. All right. Now, we look at, so what's interesting about the white dots is we need one of each digit on the white dots. So that's something to keep in mind. We need all of 1 through 6 on them. I guess what that means is we're not going to do something like 2, 3, right? If I did a 2, 3 on a white dot, then what happens is I've isolated the 1. The 1 can't go with the 2 because we can't repeat the 2. So wherever the 1 appears, which it must appear somewhere, it won't have a buddy to go with. And if I do something like 4, 5, it isolates the 6. So what we're going to end up with is one of these is 1, 2, one of them is 3, 4, and one of them is 5, 6. So I suppose that means this one can't be 5. I was thinking it could be 5, so that's why I didn't mark it. But if it was 5, this would be 4, and we have that exact problem of isolating the 6. That's not one of the allowed pairs. So this is a 1, 2, 3, 4. Now, okay, if it was green, these would have to be consecutive and add to 5, because the two greens add to 5. That would be 2, 3. But we already talked about 2, 3 not being allowed. So this is actually the purple 1, 2, 3, 4, for what it's worth. How about across a black dot? I mean, we could do 3, 6 here, which wouldn't actually color this one. So maybe we don't think about that. What about this black dot? So it can't be 1, 2. There's only 3 possible black dot pairs. There's 1, 2, there's 2, 4, and there's 3, 6. This is just scratch. It can't be 1, 2 because that would make this impossible. We can't add to 5 without a 1 or a 2. And it can't be 2, 4 because this would be 1, 3, right? 2, 4 still uses one of each of the two ways to add to 5. So the only option is to be 3, 6, which means this can't be 2, 3. This has to be 1, 4 because it can't have 3 with it. And then this has to be 5. That's 5, that's 6. So this is a 2, 3. This is a 1, 4. This is a 2, 3. And this is a 2, 3. Now that we know what they are, we don't have to give them colors anymore. And so now this is a 2, giving 3 here. Now remember, I guess this just makes this 3, 4, but I was going to say, remember, we can't make that 3, 2. That's a 1, which puts a 2 there. That's 3 and 2. All right. So this 3 ends up here. This is a 1, 2 pair. This is a 5, 6 pair. Yeah, we know the order. That's 5, that's 6. This is 1 or 4, and this is 1, 4, 5. All right, good progress. Now we have 3 and 4 here. So these are from 1, 2, 5, 6. I'm not ashamed of penciling this. In fact, this 1, 2 tells us that this can't be 1 or 2. So this is our 5, 6, and this is our 1, 2, which we know the order. Giving us the 3 and 2, and the 4, and the 5, and the 1, and the 6 and the 5, and the 1 and the 2, and the 3 and the 6, and the 4 and the 1. Over here we need 1, 4, and 5. The 1 goes here. This is just 4, 5. Down here I need a 4, 6. The 6 tells us that. That's 4, that's 6, that's 5, and that's 4. Down here we need 3, 4, and 5. This is our 3. This is our 4. This is our 5. And we're done. All right, nice puzzle, Calvinball. I liked that idea of creating regions out of the individual constraints. I think that's a neat idea and good execution. Oh, I think I clicked on a Sudoku pad thing. Okay, well, anyway, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.